Hello and good morning, ladies and gentlemen. Let me begin with the name of Allah, the most beneficent and the most merciful. I am the session chair of session number 4, energy track number 4. My name is Dr. Rabia Shaukat. I am currently working as an assistant professor in the Department of Mechanical Engineering Lahore, New Campus, UET Lahore. On the behalf of the organizing committee, I warmly welcome you all in this session of International Conference of Energy, Water and Environment, ICEWE 2021. In this session, there are 5 talks. At the end of each talk, we will be having question and answer session. The audience is requested to write the questions in the chat box during the talk. At the end of each presentation, the session manager will ask the requested questions from the presenter. Without any further delay, let me introduce our session chair, Professor Dr. Nadeem Ahmed Mufti. He is currently working as a Dean of Mechanical Engineering Department, University of Engineering and Technology, Lahore. He has done his PhD from University of Birmingham, UK. He also served as the Chairman of Mechanical Department, University of Engineering and Technology, Lahore. Thank you so very much, Professor Dr. Nadeem Ahmed Mufti, for being with us. It's an honor to have you with us, sir. Now, let me introduce our first invited speaker, the Honorable Mr. Maqsood Ali. He is the President of TSI Engineering USA. He has almost 32 years experience in construction industry in Pakistan and USA. He worked for various construction projects in NASA, Department of Energy and Transportation in United States. On the basis of his prestigious work, he also got Pride of Performance in Design Build projects in United States of America. He also nominated for the Contractor of Year award in 2017. We are so much honored to have you with us. Our first talk is with Mr. Maqsood Ali. I humbly request you, sir, to share your thoughts about the effects of construction on stream water quality.
Hi, this is Maqsood Ali, President of TSA Engineering. I'm professional licensed engineer from various states. I did my master from California State University, Sacramento. I would like to talk about the effect of construction on stream water quality. This topic might be a new in the construction industry of Pakistan. However, as a contractor, we spend a lot of money to control the pollution of storm water created by various activities during construction. Now we will learn what is the impact of construction sites on the quality of water. Construction of homes, buildings, roads, and parking lots create impervious surface which significantly alter the natural hydrology of the land by increasing the volume, velocity, and temperature of runoff and decreasing the infiltration capacity. Increase in the volume and velocity of the stormwater runoff can cause a severe stream bank erosion, flooding, and degrade the habitats, uh, biological habitats of these streams. And reducing infiltration can lower a groundwater levels and affect the drinking water supplies. In addition, a stormwater runoff moves across the surface. It picks a lot of debris and pollutant such as sediment, oils, grease, pesticides, and other toxics. These all directly affect the aquatic life, wildlife, and human health. Soil, actually, the soil exposed by the construction activities is especially vulnerable to erosion. Runoff from unstabilized construction site can result in loss of approximately 35 to 45 ton sediment per acre each year. Even during this is the construction for a short time, the site contribute more sediments into the streams as compared with the natural soil. If you look at in the forest land, it is a less than 1 acre, less than 1 ton per acre, whereas in farmland is up to 4.5 ton per acre, and on a bare soil in the construction site, as I told, it is 35 to 45 ton. Now let's see the type of erosion created by the stormwater. Is the raindrop erosion. The raindrop erosion, actually, it is the dislodging of soil particle by the raindrop. And then is a sheet erosion. A sheet erosion, the uniform removal of soil without the development of a visible water channel. And then there is rill and gully erosion, the removal actually through the formation of concentrated some runoff that creates a small and a little big channel. And finally, the stream bank erosion, uh, the stream bank flowing the water that erode the unstable stream bank. Now let's see which are the factor which impact on the construction site. Is the climate, topography of the site, soil at the site and in the surrounding area, vegetative curve. Climate, the climate actually, the frequency and the intensity and the duration of rainfall are the principal factor influencing erosion from a construction site. Topography, the longer and the steeper slope, the greater potential of erosion. And the soil texture, structure of soil, organic matter, compaction, permeability, all these things can influence the erosion rates. And also the vegetative curve. Vegetative curve can provide a number of critical benefits in preventing erosion. It absorbs the energy of raindrop, slow the velocity of runoff, and increase infiltration and help bind the soil. Let's see a few examples of water pollution created at a construction site. If you look at over here, this dozer actually working at the embankment of a river, it creating a lot of turbidity and moving, created a lot of erosion into the clean water. This is also another construction site. If you look at, the surface, this storm water actually make a lot of erosion and a lot of sediments are moving from construction site and going through the storm water drain. Also, and this project, if you look at, is also the same thing. There is no BMP. I will tell you the best management practice later on. But this site you can see can create a lot of erosion. Also here, this construction site, a lot of erosion of the particle, and is this compactor actually is working very close to the water body, and it can create a lot of erosion movement into the water. In USA, I want to tell you how the contractor actually prevent the stormwater pollution. The first thing is we prepared actually SWPP, Storm Water Pollution Prevention Plan, and then we apply the BMPs And then the third one is law enforcement, also implement the stormwater prevention plan. An effective, actually SWPP, it is a stormwater pollution prevention plan. It is the main key to control the pollution. If sediments and erosion control and good housekeeping practice are not followed at a construction activities, can result in the discharge of significant amount of sediments and other pollutants. Best management practice or BMP is term often used to describe the control and activities used to prevent the stormwater pollution. BMP can be divided into two categories. One is structural and the second is non-structural. The structural BMPs include at a site we provide the silt fence, sedimentation pond, erosion control blanket, and temporary or permanent seeding. And whereas non-structural BMPs include picking a trash at a site, debris, sweeping on the sidewalk, street, maintaining equipment, training the site staff on erosion and sediment control practice, all these things. And third one is the law enforcement. Now let's see what is the stormwater pollution prevention plan. Actually, it's not only about the erosion control, but it also includes the description of site and all the major activities to be performed at a site, and role and the responsibility of the contractor and the subcontractor, and also it includes the inspection schedule and logs. All these items are included in SWPP, and that document is implemented at a site to control the pollution. In SWPP, they also described the site-specific best management practice (BMPs). There are a few photo of the project site where we applied the best management practice. Located at a construction site, we provide a fiber roll and straw wattles, and here is a silt fencing to control so that the sediment and any pollution cannot flow out from the construction site. Here is a slope protection, temporary slope protection provided by applying some plastic sheets over there. And on this side, if you look at slope surface stabilization, we did permanent hydroseeding so that the sediments cannot move from this embankment. And similarly, here is another silt fencing is also provided in the construction site so that on the construction site, the sediment cannot flow out from the construction site. And there is another BMP which is at the provided at the site entrance over here in all our project. At the site entrance, we provide some crushed rock and rumble plate so that the tire transportation truck cannot take out any soil out from the site. This is another BMPs. All the stockpile at a project site are fully covered with the plastic sheet during a rain event. And even we, in the USA, we don't wash the concrete anywhere at a site. It should be in a controlled concrete washed out area, which properly disposed of at the recycling facility. And now the question arises how we can implement all the BMPs and other good practice to control the pollution created by at the construction site. Do we need a storm water laws and regulation in the construction industry? Yes, definitely. In the USA, it is there are federal and state and local laws, and here I would recommend the federal government actually needs to be implement some laws, and then it needs to be enforced the provincial government, and then divisional and district level, local government, and all these regulation needs to be in the form of a stormwater prevention plan, and so that the contractor can apply at a site. Now, in USA, how these regulation and laws are enforced at a site. The inspector, city inspector, district inspector, or sometimes the state inspector visit the site after the rain event, even before the rain event, and give a verbal warning, and then the staff actually they enforce it. And if it is not fixed, then they write a letter, and finally they give a notice of violation. After receiving a notice of violation, the contractor, the government authority actually they impose the penalty to the contractor, and even their license can also be affected. In federal and California stormwater violations, actually there is a $3,500 per day for any violation they can impose this much penalty to the. Now, as I described that the construction site create actually the major pollution on the storm water, uh, and what are its measure? In the USA, actually, what we do, and the same thing I would like if it can be implemented over here in the Pakistan. There are two type of measure which needs to be implemented. One is the general measure. It include the public awareness. They should be the media is very strong. It needs to be go through the media, and also the educate some of the people. And the third one is the law enforcement. There should be some rules and regulations so that the government can enforce the rules and regulation on the contractor or any person who generate the pollution for the storm water. And the second one is actually site-specific measure at a construction site. At a construction site needs to be stabilized. During the construction, provide the best management practice as much as possible. Protect slope and channel, like the topography of the soil and surrounding slopes and channel needs to be protected by providing a BMPs. Reduce impervious surface and promote infiltration. All the impervious surface in that area needs to be reduced. Like, the roof water it needs to be go into the landscape area where the water can infiltrate into the ground. And also it needs to be control the site parameter, protect adjacent water bodies. If the construction site is very close to the any river or any lake area, it needs to be give high importance factor at a site, and also the finally follow the um, SWPP to implement at a site. I hope you guys learn and enjoy the how the construction site affect on the quality of stream water and how it can be prevented from any pollution. At the end, I'm grateful and proud to call myself as a UET alumni. I'm honored to have the opportunity to work alongside the ICEW organizer. I'm very thankful to all the organizers of ICEW. Thank you very much. These are the references actually US Environmental Protection Agency and the California Water Quality Board, Control Board. These are the enforcing agency. And guys, thank you very much. I really appreciate it.
Thank you very much, Mr. Maqsood Ali, for the brilliant talk. If the audience have any question, you can ask in the chat box. Please write your questions in the chat box.
Thank you so much, Mr. Maqsood Ali.
Hi, thank you. Yeah, this is Maqsood Ali, and thanks for giving me an opportunity. I don't think so. I could not find any question.
Yeah, there is one question in the chat box, and it's like, are there any BMPs and SWPPs are currently applied in Pakistan?
I think not in Pakistan. That's why I have requested it should be implemented over there to protect the environment.
Thank you so much. Thank you so much for your time.
Thank you.
Now, quickly moving forward, we have Dr. Muhammad Zaka Imad from UET Lahore joining us. The title of his presentation is Overview of Lithium Resources for Lithium-Ion Batteries and Way Forward. I would humbly request Dr. Muhammad Zaka to please share your thoughts. Thank you so much.
Assalamu alaikum and good morning to everyone. I am Dr. Zaka Imad and I am presenting this presentation at the International Conference of Energy, Water and Environment on the topic of an insight of lithium resources, mining, environmental aspects, and way forward. I'm presenting this presentation on behalf of my co-authors, Dr. Yasir Majid, Dr. Zulfikar Ali, and Dr. Badar Hayat. I would also like to thank the organizing committee of the conference for letting me present this presentation. So let's get started. That's the presentation outline that we have. I'll start with the background of whatever I'm talking about, the problem statement and the lithium resources around the world and in Pakistan with the focus of Pakistan. Then I'll talk about the mining of lithium and the processing technologies that we have so far available. And there is an environmental aspect or environmental impact of all this mining and processing technologies. So I'm going to we're going to discuss that in this presentation. And finally, the discussion and or the way forward. Let's get started. So the lithium ion batteries are generally dominating the industry because they're really environmental friendly and there's a high energy density in these batteries. So they are really popular for the electric vehicles and equipment and other equipment like the laptops and other portable equipment, whatever we have. But the thing is, the lithium resource is really scarce. So there are not many deposits in around the world. There are very small deposits that are being worked. The production is really low. So let's look at some of the things like you need. So if the deposit is really small, the resources is really very small, then we must look into the assessment of the available resources, whatever we have, how we can take it out, how we can mine it, how we can process it in a better way, in an environmental friendly way, and if like there's a chance of recycling of the lithium batteries, we should really look into high-tech solutions for that. Also, we need to think about the environmental aspect of the recycling as well. So these are a few things we should be looking after. So what's the benefit? We want the lithium-ion battery to be the industry of lithium-ion battery to be really sustainable, and it should really progress for our future, for the future of the human race. So the second thing is the study that this particular study will help us develop some of the policies or will direct the stakeholders towards some of the policies that are relevant to the lithium mining and processing and the recycling. So this will probably help the stakeholders develop new policies. So let's talk about the resources we have in the world. Right now, we have let me just annotate. So we have these resources in North America and South America. These are the big balls that I have, the big spheres that I have on this map, world map in the in South America, Bolivia, in particular, Argentina and Chile. These are the big deposits that we have. There are some of the smaller deposits or relatively smaller deposits are there in Canada and America. There are some deposits in Australia, in Africa, in Europe, and some are there in China and other East Asian countries. So these are the deposits that we have. So the total production we get is 82,000 tons per year. And this is really good for the demand that we have right now. Actually, it will, if we are going to have this demand throughout our lives, then we are good for 350 years or so. Like it will last for more than that. So we are good with lithium. But the thing is, the electric vehicles are getting into the business right now, and probably we have to think about some other things, because once more than half of the population will have of the world will have these vehicles, these electric vehicles, then probably there will be a shortage of lithium. So with all those deposits that we have, these are not the mining deposits. So we have to think about the mineability of these deposits. So are these deposits feasible to mine, economical to mine? We have to have processing techniques available to process that deposit, because generally what we have is the grade of the lithium in those ore deposits in the earth is 2.6% lithium. And we have to make it 99.9% pure or more than 99% pure with the processing and with the refining technologies that we have. So if we look at the current deposits that we are mining or current mines, whatever is their capacity, and with the demands, with the upcoming demands, like with the projected demands, our deposits will not last more than 10 years. Whatever we are mining right now, they are not going to last for more than 10 years. So there's a need to develop some of the new technologies in mining and processing. So as far as Pakistan is concerned, there are 3 small deposits. One is Naga Parbat, one is Naga Parbat, the other is Nawagali deposit, the third is Gidarpur deposit. So one is at the Indian border, at the Kashmir border. The other one is in KPK, and the third one is near Naga Parbat. So these are the 3 deposits that we have. But the good thing is Afghanistan has got really big deposits near the border areas, like these particular areas. It has the world's largest deposits of lithium that are being worked on, like the exploration is going on, and there are big prospects here. So probably if these deposits are here, there will be some traces here as well in Pakistani side. So probably we can look into it. Also, we can also take advantage of the deposits in Afghanistan. We can work on it. We can develop some of the battery processing plant or something, production plants here. So that will really help us. Right. So for the lithium mining, there are open pit mines for the lithium. So these are the hard rock mines that we work on. Similarly, we have the underground mines. So when the open pit mine is not feasible, we go underground, we try to take up lithium as much as we can. The third type of deposits we have is salt brine deposits, and the salt brine deposits are basically salt lakes kind of deposit, and there are lithium traces in there. So they pump this whole thing, and they dry it out, and they remove the salt particles, salt materials, salts, and from salts they process, and they get lithium out of it. These are the three main types of things. So when we talk about processing, there are certain inputs like the raw materials, the mineral, or the ores, and the fuel goes in there into the process. The chemical reagents go in there, and the thermal energy and all that stuff. So there are then you have to do the processing. Like for the mining thing, you have the pegmatites ore deposits, and you have to do the blasting. Then you go for the excavation, comminution, separation. So all these processes are in the processing part of the lithium. So once you're done, you end up with the lithium carbonate. So the second stream is for the brine. So when you have the brine or salt lake anywhere, you pump the brine out of it, concentrate it, you remove the impurities, and then you go for settling, filtering, and heating and precipitation, and then thickening and drying. In the end, again, you're gonna get lithium carbonate. So all of this processes involve a lot of chemicals, a lot of fuel and electricity and thermal energy. So there will be some environmental impacts like the atmospheric emissions, like the solid waste, the water pollution is there as well. So these are the things that we must look into it. So, or we have to improve this process. The mining and the processing process needs to be improved for this. Right. So in terms of environmental impacts, it can be due to mining and processing. You're doing blasting. You're removing the topsoil, the vegetation. The flora and fauna will be damaged, and there will be problems with the groundwater. There will be problems with the flora and fauna of that particular area. There will be damage to ozone. The air contamination will be there. The air pollution will be there. So these are some of the things that are due to mining and processing of lithium. So what is the way forward for it? We have to think about the sustainability of lithium resources, and that must be translating into supply to meet the future demands. We have very little mines, very little mines that are working on smaller deposits. So we need to work on the larger deposits. We need to find environmental solutions because lithium mining is really hazardous, and there are consequences, there are problems when they mine out lithium, when they process it. So there's a need to find better solutions for that. There's also a need to find out if there are any other deposits in far-flung areas like maybe Alaska or maybe Antarctica or under the sea. Maybe in the seabed there are some deposits. So we need to look deeper, find more deposits, because this is really the technology of the future. We need to look into it. We are relying on it. So that's one thing. So the next thing is the R&D. The research and development needs to be developed. There is more money to be given to mining and processing side. Also, we have to look into the recycling method, and also we have to compute the cost and the environmental. We have to create the environmental friendlier methods for the processing of this lithium. Right, so that's about it for this presentation. These are some of the references that I've used for this work. Right, so that's about it for the presentation. Thank you very much for giving me a chance to present my work. I would look forward to your question and answer during the conference. Thank you very much.
Thank you so much, Dr. Muhammad Zaka. If the audience have any question, they can write it in the chat box.
Thank you so much, Mr. Zaka. We have got one question from the audience. Why Word is not utilizing half your full burden to the zinc ion batteries?
The full burden what they're doing is
Can you speak a little bit louder? Sorry, yes.
Right. So my talk was about the.
I think so. There is some issue. We can't hear you. Okay, let me move further. Because of the time limitations, we have to complete the session in the limited slot. Thank you.
Now I would like to introduce our third speaker, Muhammad Uqba bin Ubaid Butt. He is from Bahauddin Zukriya University, Multan. I would humbly request him to share his thoughts about a short review on personal cooling garments for laborers. Thank you so much.
Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Myself, Muhammad Uqba bin Ubaid, and the topic that I'm going to present here today is a short review on personal cooling garments for laborers. My co-authors are Muhammad Hamid Mahmood, Muhammad Sultan, and Muhammad Numan Ashraf. And we are from Agriculture Engineering Department, Bahauddin Zikriya University, Multan. Moving forward, as we all know, laborers, either they may be working on a construction site or in an agriculture field, they work directly under the sun for long hours, which make them prone to heat-related diseases like heat stroke, heat cramps, heat stress, etc. Whenever the human body is exposed to such kind of harsh environments, and we add in the physical work, that will ultimately result in the heat stress of the body that will reduce the working endurance and performance of the human body. So personal cooling garments were introduced as a solution for this, but they were primarily developed to reduce or avoid heat strain in hostile aerospace and industrial environments. But with the passage of time, researchers found its multiple uses. So nowadays, personal cooling garments are used for kinds of work where laborers are in contact or introduced to fire directly, like firefighters or metal smelters, and for laborers working on a construction sites. Here, as we know that human comfort is a difficult term to define. It depends upon various things from the humidity, the relative humidity of the atmosphere, of the air speed, air temperature, radiant temperature, metabolic rate, or insulation provided by clothing. So it varies from different types of cloth. So human comfort is summation of all these parameters. So to feel comfort in a particular environment, these six factors has to be on the right conditions. Under the right conditions of these six parameters, that the human body feel thermally comfortable. The heat exchange that occurs in a human body can be expressed mathematically as M minus W is equal to E plus R plus C plus K plus S, where M is metabolic rate or heat produced by the human body under the result of the food consumed, and then W is physical work, or physical work. So that's basically called the when human body consumes food, it comes converted into energy or heat, or the amount of heat utilized to do physical work is subtracted, then S is equal to rate of heat storage. For human body to be thermally equilibrium, this should be zero. So there should be no heat stored in the human body for an equilibrium or for maintaining the human body core temperature. S, so K is heat transfer from the body through conduction, C is heat transfer through convection, R is heat transfer through radiation, E is heat transfer from body in form of sweat evaporation. Sweat evaporation is basically human body natural mechanism to cool itself. Forward, this is a graphical representation of human comfort zone on a psychometric chart as standardized by ASHRAE. Here you can see this green zone is the zone where human body feel most comfortable. Moving forward from this is a caution, so where we have to the human body sustain under the caution zone and even in extreme caution zone. But this in extreme caution zone, the chances to heat related diseases increases, so we have to keep the body towards the caution zone minimally. So human body, as you know, during different physical action produces heat. So this heat, as we know that with the as we discussed in the equation, so should be transferred through the from the body either from conduction, convection, or sweat evaporation. So the normal body heat the core temperature of the human body is 37 degree, and this is maintained and achieved by balancing the amount of heat produced by the body to the heat lost. So typically there are three types of personal cooling garments. Those are liquid cool garments and air cool garments and phase change material. We'll discuss them. So liquid cool garments, as you know, shown from the clear from the name, are the garments which utilize water or any other aqueous solution as coolant. So in liquid cooling garments, there is a coolant to cool, external coolant to cool the human body. It's a kind of, so there's a tubing in which the coolant is present and it is circulated through a pump, micro pump operated by a battery. So there is a sump where the coolant after taking the heat from the human body is go and then cool itself down, and the process is again done. So it is one of the most widely used personal cooling system. Liquid cooling is most widely used personal cooling system, and it is highly recommended where the protective clothing is required. Under the protective clothing, liquid cooling garments are the best garment to cool the human body. Means some kind, just in some conditions like people who works in fire as a firefighters, they need that extra cooling. Those who works with heavy suits like astronauts and those like who's work in the bomb squads, so they need though the cooling that provided to them is mostly through liquid cool garments. Moving forward, we have air cool garments. Air cool garments basically utilize human natural mechanism of sweat evaporation. So it's contained of a cylinder of air that was exposed to the body that will cause the fast evaporation of the sweat. So sweat evaporation is, as you know, directly affected by the exposed area, and it's mostly contained of the two layers, one of outer layer containing impermeable cloth and inner layer of a permeable material, so the air could pass from them. Or these both liquid cool garments and air cool garments are known as active cooling garments because they require a power source to operate. Then we have phase change garments. Phase change garments are known as passive garments, passive cooling garments, because they doesn't require an external energy source to operate them. So phase change material are per use latent heat storage of the material. So PCM garments so also known as passive cooling system, as it does not require. So mostly PCMs, mostly used PCM materials in personal cooling garment includes frozen water, paraffin wax, and dry ice. Paraffin wax is mostly used as a phase change material. It actually contains packets, different number of packets revolving around the human body torso, and these are the ideal placements of personal cooling garments. Yeah, these are from, as you know, front, as for the front, and these are from the back. So as we can conclude here that personal cooling garments can be the most feasible solution for providing thermal comforts to labor where engineering or administrative approaches are not feasible. As we know that the laborers, as we can say, that the laborers who works in farms, on the field, on the construction sites. So there is not typically on a structure where we could find air conditioning or etc. So engineering approaches or administrative approaches are not sufficient in these conditions. So personal cooling garments are introduced as the best feasible solution for this, for these labors under these circumstances. It also enhances the working performance of laborers with protective clothing. As know that under protective clothing, it heavily causes sweating. So under the protective clothing, this is highly recommended. And liquid cool garments are found to be the best where cooling with protective clothing is required. And the presented work is accomplished under the inspiring leadership or inspired supervision of Dr. Muhammad Hamid Mahmood and Dr. Muhammad Sultan. I humbly thank them for their effort and their time. And these are the references. And that's all from me. Thank you very much. I hope you have a great day. Assalamu alaikum.
Thank you so much, Muhammad Uqba bin Ubaid, for your presentation. If the audience has any questions, please write them into the chat box. Thank you. Now, I would like to invite Ali Ayub Danial from UET Texla in order to present his thoughts about mathematical modeling of ablation mechanism during nanosecond pulse electron beam processing of thin films for solar cell applications. Thank you so much.
I starts with the name of Almighty, the gracious, the merciful. Respected panel of professors, faculty members, organizer of this conference, ladies and gentlemen, I am Ali Ayub Danial. I am doing my master's in mechanical engineering from University of Engineering and Technology, Texla. Today I am going to present my research work, that is mathematical modeling of ablation mechanism during nanosecond pulse electron beam processing of thin filming for solar cell applications. This is the sequence of my presentation. First is the brief introduction about thin filming, then the objective of my research work, pulse electron deposition process, the fundamental stages that are involved in this process, then the mathematical model that has been developed in our research work. Then are the simulation results and their discussions, model assessment based on the literature, and the conclusion. So thin filming is a process in which a layer of material is deposited on a substrate. Thickness of that material can range from few nanometers to a few micrometers. It has vast range of applications. Few of them are listed here. Wear and corrosion resistance coating, electrically and optically active coating, magnetic thin films. Thin films are produced by various processes. The conventional one is pulse laser deposition process that is quite established. And then there is a quite novel technique that has recently gained attention, and that is pulse electron deposition process. This technique has promising advantages over pulse laser deposition process. One is high energy transfer rate, that is approximately 30% more than that of PLA. Process scalability, low capital and operating costs, smaller equipment footprint. These are the objectives of my research. Through literature review, it has been revealed that mechanism of surface ablation during beam-target interaction is still not understood completely. And above that, ablation mechanism is not always amiable to the experimental studies. Therefore, there is a need to establish a complete mathematical model to understand this complex phenomenon. For that reason, in our research, a one-dimensional thermal model based on two-stage heat conduction equation is employed. Two stages, it will be explained in the later slide. One is before melting, when the target is solid, and then after melting, when it converts into liquid and eventually evaporate and to form a thin film on the substrate. So pulse electron deposition has four fundamental processes. First one is the generation of pulsed electron. It is through a hollow cathode where the electrons are produced and then accelerated through a dielectric channel on towards the target material. Then comes the stage 2, where the electron strikes the target material. Since they are of high power density, approximately ranging from 10 to raise power 8 to 10 to raise power 12 watt per centimeter scales. Therefore, the temperature of the target material starts to rise, and a plasma pellium expand in the background gases. This is the stage 3, and eventually it forms a thin layer and solidify on the substrate. Mathematical model. So as already stated, that there are two stages. One is before melting and other is after melting. Before melting is when it is in solid phase. The thermal diffusion along the target depth can be described by one-dimensional thermal heat conduction equation, which is given as below. With its initial and boundary condition. In this, rho s, Cps, and Ks are solid phase densities, specific heat capacity, and thermal conductivity of the target material. So then the liquid phase, when the target material starts to melt and it is converted into liquid phase. Here again, rho L is the liquid state density of the target material, Cpl is the specific heat capacity, and Kl is the thermal conductivity. Initial and boundary conditions are given. These are the equations that are used for the simulation. Simulations are performed on COMSOL multiphysics. Melting. When the rapid melting and solidification take place, the melting rate is assumed to be controlled by interface kinetics instead of thermal diffusion at the interface, which is explained by the given equation, where Um and Tmi are the kinetic melting coefficient and melting temperature interface. And vaporization dynamics due to target surface irradiation by the electron beam is primarily determined by the surface temperature of the target. When irradiated by the irradiated target surface reaches the boiling temperature, recession of the ablated surface starts to occur due to vaporization. This is explained by Hertz-Knudsen equation of vaporization, which is given. In this equation, Ps is the saturated vapor pressure just above the target surface. M is the average mass of the target particle, and Ts is the surface temperature. So beam heat source interaction. When the electron beam produced in the channel sparks come in contact with the target surface. This mechanism of energy transfer during electron beam ablation is predominantly based on the collision between the electrons and the electrons of the target material. The analytical expression of maximum energy deposited by each group of electron can be fitted in the given polynomial function. There are three groups of electron which will be explained in the next slide because it is of the results. Three group of electrons: group A electron, high energy electrons that range from 5 to 16 kilo electron volt. Then group B electrons that range from 1.8 to 5 kilo electron volt, and then the group C electron, which is less than 1.8 kilo electron volts. So these simulations are performed on casino program. Monte Carlo simulations are performed. From the graph, it can be seen that the temperature is not on the surface, is not highest at the target surface. Rather, it just beneath the target surface where the temperature is at its peak. So if we can see, it is almost 1/3 of the penetration depth, total penetration depth that is achieved by each group of electrons. And for group of electrons, greater the energy of the electron, greater will be the penetration depth. This graph explains that. So for group A electron, maximum penetration depth that is attained is 274 nanometers. And 45 nanometers is for group B electron, and similarly for group C electron, it is 7 nanometers. So target surface temperature. It can be seen that it is a function of the efficiency of the electron beam. For higher efficiency, around 60 to 80%, the target temperature attained is around 8,000 Kelvin. And for lower, it will keep on going low. Surface recession velocity. The recession velocity for the target surface calculated for the different efficiencies at backflux coefficient of 0.18 is presented in this graph. It can be observed that surface recession velocity profile visibly reflect the Gaussian electron beam intensity distribution at the target. At higher value of the efficiency, around 60 to 80, the surface recession velocities increase with the time due to the steady energy accumulation during the period of the entire pulse duration. Then the ablated depth. The ablated depth is the melt depth calculated for various values of efficiencies. As can be seen in the graph, the anticipated case of 80% efficiency, the melt depth is nearly 10 micrometers and is greater than that for the other values of the efficiencies. An ablated mass per unit area. The ablated mass increases steadily as a function of the pulse duration and reaches the maximum value of 3.8 microgram per millimeter square. Model assessment is based on the literature review. If the beam intensity is sufficient enough, then a certain layer can be approximately 1 micrometer can be ablated. This is reasonably in agreement with our calculated ablation depth of 0.65 micrometer. Ablated mass per unit area via pulse electron deposition is 5 to 10 times greater than that of pulse laser deposition process. According to the results obtained, the target ablation seems to take place primarily in the region of melting and vaporization for the surface. So there is no sublimation involved that has previously been stated in few of the researchers. So in conclusion, a two-stage one-dimensional heat conduction model is presented. finite element analysis is performed. Surface recession velocity, ablation depth, ablated mass per unit area are also calculated. Calculation results are compared with the available experimental data in the literature. It is concluded that target ablation via pulse electron beam ablation process take place via melting instead of sublimation. These are the references, few of the references. Awaiting questions. Thank you very much.
Thank you so very much, Mr. Ali Ayub. If the audience has any questions, please write them into the chat box. Thank you.
He is not available, so let's move forward.
Now I would like to invite Muhammad Noman Ashraf from the Bahauddin Zikriya University, Multan, in order to present his work on study on carbon dioxide separation from flue gases using adsorption technique. Thank you so much.
Assalamu alaikum. I am Muhammad Noman Ashraf. I am going to present my research work titled as Study on CO2 Separation from Flue Gases by Adsorption. Let's start with the background. As a matter of fact, fossil fuels are the primary energy sources used worldwide to meet the increasing energy demand. The combustion process of these fossil fuels emit large amount of carbon dioxide gas into the atmosphere. As we can see in this figure, that the carbon dioxide concentration in the atmosphere has increased rapidly from 2010 up to 2021 and reached up to a level of 420 ppm, which is creating an alarming situation for the atmospheric chemistry of the globe. Furthermore, climate change and global warming are the associated problem with the higher concentration of carbon dioxide gas in the atmosphere. So there is need to control the carbon dioxide concentration in the atmosphere. There are many possible solutions for the problem, but carbon capture and storage is one of the promising solutions to the problem. Let's see the design of the carbon capture and storage system. Basically, carbon capture and storage system consists of two processes. The first process is to capture carbon dioxide gas, and second is to transfer it to a storage site where it can be stored under high pressure. The left figure shows two scenarios of carbon dioxide gas capture: post-combustion carbon dioxide gas capture scenario and the pre-combustion carbon dioxide gas scenario. In the post-combustion carbon dioxide gas scenario, the carbon dioxide gas is captured after the combustion of the fuel from the flue gases emitted in the combustion process. While in the pre-combustion CO2 capture, the carbon dioxide gas is captured during the gasification or shift reaction process before the final combustion of the fuel. The figure on the right side shows the physical adsorption-based carbon dioxide capture. As we can see that flue gases are emitted from a point source which passes through a physical adsorbent. The physical adsorbent captures carbon dioxide gas on its surface while allowing other gases to pass through it. This is due to the higher selectivity of a higher carbon dioxide selectivity of a specific material. After the adsorption of the carbon dioxide on the material has to be regenerated for further use. There are basically three processes involved in regeneration process: pressure swing adsorption, temperature swing adsorption, and vacuum swing adsorption. Pressure swing adsorption and vacuum swing adsorption uses the change of pressure to regenerate the material, which is a difficult task. While in temperature swing adsorption, The material is regenerated by heating the material up to a specific temperature where it can dissolve the adsorbed carbon dioxide gas. This figure shows the regeneration process by temperature swing adsorption. There are two cycles in this process, adsorption cycle and desorption cycle. In the adsorption cycle, flue gases enters into the material and carbon dioxide gas started to be adsorbed on the surface of the material. The green color shows the carbon dioxide concentration, while orange color shows nitrogen concentration. As the green color increases, which means higher adsorption of carbon dioxide gas till the saturation point occur. Then the material is heated to a specific temperature known as desorption temperature to regenerate the material. The carbon dioxide gas started to dissolve. Further, nitrogen gas is purged into the material to completely dissolve the adsorbed carbon dioxide gas from the material. Next is the different adsorbent used for the post-combustion carbon dioxide capture. First one is the metal organic frameworks, which are the three-dimensional network of polymers constructed by metal ions or clusters connected with organic ligand. This figure shows the surface structure of different commonly used MOFs, while this figure shows the adsorption isotherms of different materials under different temperature and pressure condition. We can see that the adsorption of carbon dioxide on a specific material mainly depend upon two factors, pressure and the temperature. Here we can see that all the MOF adsorbents shows almost similar behavior depending upon changing the temperature and pressure. At higher pressures, the adsorption of the carbon dioxide gas increases, while when we increase the temperature of the material, the adsorption reduces. The next material is the zeolites, which are the porous adsorbent made up of microporous crystalline frameworks. Silicon and aluminum are the main constituent of these materials. This figure shows the structure of commonly used zeolite known as 13X, while this figure shows the adsorption isotherm of two different materials and their parental materials. Next is the porous organic polymers, which includes various types of polymers and frameworks. These polymers are mainly constructed by the functionalization of different parental materials. This figure shows the functionalization process in which some other material is purged into the parental material to create a new material which has higher porosity and surface functionalization. While this figure shows the gas uptake of a specific porous organic polymer material. Here we can see that highest uptake was of carbon dioxide gas, then other two gases, which are methane and nitrogen. This is due to the higher selectivity of the specific porous organic material. Next are the conclusions of this work. We found that metal organic frameworks can perform better for carbon dioxide capture in humid conditions, while zeolites were found to be more attractive in dry conditions. The heat of adsorption of zeolites is comparatively lesser in physisorption process than that in chemisorption process. Future recommendations are the researcher should focus on surface functionalization of porous material for cost-effective and sustainable development of carbon dioxide industry. The present work is accomplished under the inspiring leadership and vibrant supervision of Dr. Muhammad Hamid Mahmood and Dr. Muhammad Sultan, the Department of Agricultural Engineering, Bahauddin Zikriya University, Multan. These are the references cited in this presentation. Thank you.
Thank you so very much, Mr. Muhammad Noman Ashraf. If the audience has any questions, please write it into the chat box.
Thank you so much, Mr. Noman Ashraf. There is one question. Are these absorption columns are economically feasible and more efficient as compared to the other previous methods?
Thank you for your question. Actually, this is not an so economically feasible process. That's why it is not penetrating in the market. However, it is comparatively economical than other methods of carbon dioxide capture.
Thank you so much. Thank you so much.
Thank you. On the behalf of the organizing committee of ICEWE 2021, I am thankful to the session chair, Professor Dr. Nadeem Ahmed Mufti, our invited speaker, Dr. Maqsood Ali, all the distinguished presenters and the participants. It was a wonderful session and I hope the audience had enjoyed it. Hope to see you all in the next session as well. We have other sessions running in parallel and the industrial exhibition also showcased on our website. So enjoy our exhibition and parallel sessions. Thank you once again for sparing time for this productive session. Thank you so much.